Hello everybody, welcome back. This is our first lesson in Unit 4. Unit 4 is called moles, and you'll see a lovely little picture of a mole. So we'll get into what that means later on in this unit, but today we're going to start by learning about significant figures. So in the last video, or last set of videos rather, we cover all of Unit 4B, so covalent bonds, molecular bond polarity, intermolecular forces, and all that good stuff. So in this video, we'll cover what significant figures are, how to determine if a number is significant or not, and then how to use them in mathematical operations. So what are significant figures? If you were to look this up in your textbook, because that's exactly what you do when you don't know something, it would say all the digits that can be precisely known in a measurement plus a last estimated digit. So basically, that's what a significant figure is. It's describing basically how precise something can be. So if you were, let's say, measuring water in a graduated cylinder, you know this is 1, 2, 3, say 4, this is not drawn to scale, 5, and we're like, okay, cool, what is this measurement? You might say, oh, well, I know it has to be at least 4, and it's because it's about between 4 and 5, you would say 4.5. So basically what a sig fig is, it's what you can measure plus that one guess. Now, you didn't know exactly that it was 4.5. It could have been 0.6, it could have been 0.4. So that's what we mean by that last number being an estimated guess. So it's what you can measure plus one number. Okay, so how do we know if something is significant? There are a bunch of rules that we're going to go over. And just to kind of give you a heads up, when we do calculations moving forward, we'll try to use sig figs. And then if you move on to physics, you will revisit it again. Okay, so rule number 1 says, you were looking up in the textbook, every non-zero digit is in a reported measurement is assumed to be significant. Okay, again, textbook definitions don't make much sense. What you need to know is that all non-zeros are significant. So if a number is not 0, it is significant. So 1 is significant, 2, 3, 4, 5, 6, 7, 8, 9. All of those numbers are significant. Smack them together, you have a few significant numbers. So let's kind of go over what that means. Here we have 5. 5 is not 0. And there is one number. So that's one significant figure. Basically the number of numbers. Next one, we have 3, 2, 3, 4. All these are non-zeros. All 3 of them are significant. So when we're talking about non-zero numbers, it's basically the number of numbers that are not 0. We'll talk about zeros in a second. There are a handful of rules that go over zeros, but let's just stick with this right now. So here we have 3, 9, 8, 4, 7, 1. There are 6 figs because there are 6 numbers that are not 0. That's the easiest rule with this. And the last one, we have 9, 4, 8, 2, 7. How many sig figs do you think we have? Hopefully you all said 5. Okay, so now that we've talked about non-zero numbers, let's talk about zero numbers. Well, numbers that are 0, so 0. So rule number 2 says zeros appearing between non-zeros are significant. So what you need to know is that sandwich zeros are significant. So what I mean by sandwich zeros is that the 0 that is in between two numbers that are not 0. So because it's stuck in the middle, it's sandwiched between two numbers that are not 0, we say that 0 is significant. There are 3 sig figs. So in the next one, both of these zeros, they're stuck in the middle of the number. So both of those zeros are significant, and in total, we have 1, 2, 3, 4, 5 sig figs. The third one, this 0 is sandwiched in between, and these two zeros are sandwiched, or stuck in the middle of that number, so they are all significant. So you have 1, 2, 3, 4, 5, 6 significant figures. And with the last one, how many sig figs do you have? So you should have said 1, 2, 3, 4, 5, 6, 7 significant figures. So I get a highlighter here. That 0 is significant, this one is, and that one is, because they are sandwiched in between numbers that are not 0. Okay. Number 3. Again, there is a long textbook definition. Not even going to read it. You guys are capable of that. But what you need to know is that the leading zeros are not significant. So what is a leading zero? Well, this is a leading zero. So we have numbers that are not 0. And then because that 0 is in front, it's a leading 0. Not significant. We don't care about it. It just acts as a placeholder. So there are only 3 significant figures in this example. In the next one, we have these 3 zeros. Now they all come before the number. They are not significant. They are leading zeros. The only thing we care about are those 3 numbers. And again, we have 3 sig figs. In this example, we have all of these numbers, all of these zeros highlighted in blue. They are leading. They are not significant. But we have another 0 right here. Is that 0 significant? Why? So you should have said this 0 is significant because it is a sandwich 0. So with this being significant, we have 1, 2, 3, 4 significant figures. And lastly, again, these leading zeros, not significant, we don't care about it. This one, well, let me ask you, how many sig figs are in this number? You should say 4, because this 0 is significant because it is a sandwich 0. Okay. So number 4, again, long textbook definition. The what you need to know part is the trailing zeros. So a trailing 0 are significant if there is a decimal point. So what I mean by that is right here you have that decimal point. So that means if there is a decimal point, all the trailing zeros, so numbers towards the end of the number, those are trailing, are significant because that decimal place is there. So that would be 4 significant figures. We have 1, 2, 3, 4. These zeros are significant because that decimal point is there. In our next example, we have a decimal point. So that means all of these zeros are significant. So that means in total we have 1, 2, 3, 4, 5, 6 significant figures. The next one, so now we're adding on a bunch of rules. Let's kind of go over this step by step. So this blue 0, not significant because it is a leading 0. This 0 is significant because it is a sandwich 0. So we like that one. This one in orange is also significant because it's a trailing 0 and there is a decimal point. There is a decimal point. So in total in this example, we have 1, 2, 3, 4, 5 significant figures. So go ahead and try this one. How many sig figs are in this example? And so hopefully you said 1, 2, 3, 4, 5, 6, 7, 8. 8 significant figures. So these 2 trailing zeros are significant because you have that decimal point there. Okay, rule number 5. Here's your textbook definition. So what this says, trailing zeros are not significant if the decimal point is absent. So no decimal point, trailing zeros are not significant. So if we look at this example, we have some zeros. Now this first one is significant because it is a sandwich 0. But these 2 are not. If you notice, there is no decimal point. So that means the trailing zeros are not significant. So with that, We don't care about those. We have 1, 2, 3, 4 significant figures. Now, if we had 503,400 with the decimal point, this goes back to that previous rule. If you have a decimal point, then the trailing zeros are significant. That would be 1, 2, 3, 4, 5, 6 sig figs. So you have to be careful if you have a decimal point or not. Okay, 200. Again, no decimal point, only one significant figure. In this example, we have this 0 and these zeros. The first 0 right here is significant because it's a sandwich 0. These zeros are not significant because there is no decimal point, meaning we only have 4 significant figures. So try this one. What do you think? How many sig figs are here? Hopefully you said 1, 2, 3, 4, 5 significant figures. So again, these three zeros are significant because they are sandwich zeros. This one, that last one, is not because there is no decimal point. So just to kind of go back a second, with these, and we're talking about, so we had 3, 3, 4, and 4 significant figures. If you have a number with a bunch of leading zeros, you can kind of avoid that by writing them in scientific notation. So again, this one would be written as 2.033 times 10 to the 1, 2, 3, 4, 5, 6, negative 6. So whenever you see a scientific notation and it asks about how many sig figs you have, it's literally just the number that is there. So those are the same number written both ways, but the scientific notation method is easier to see the number of significant figures. Same thing goes for this one. Okay. So number 6, again, here is a long textbook definition. What you need to know is that exact counts and known conversions have unlimited significant figures. So for example, I could count 34 people in a classroom. There will always be 12 things in a dozen. There will always be 60 minutes in an hour. So because that's not changing, if you're ever doing a calculation with these types of conversions or these known numbers, then you can just kind of ignore it. When we talk about sig figs and calculations, this might make more sense, but you just kind of ignore that number. And when we get to something called dimensional analysis in the next video or so, we will talk about that again. Okay, so when we're talking about calculations with significant figures, this is really where all this kind of boils down to. So we're going to look at addition and subtraction, and then multiplication and division separately. So with addition and subtraction, what you're going to do, again, you have that long textbook definition, is round to the same place as the number with the least number of decimal places. So what that means is that we have this number and this number. Now number, let's call this A, call this B. A has 2 decimal places, but B has 3 decimal places. So you can only round to the same place with the least number of decimal places. So that's this number. That has the least number of decimal places. There are 2 of them. So that means this needs to be rounded to 2 decimal places. And that would be 9.57. Now, when we're talking about addition and subtraction, it doesn't matter the numbers before the decimal places. It's just talking about the decimal places. So if we get rid of that, here we have, okay. So here we have 81 and 412.12. Now, 81 has no decimal places, and 4.12 has 2 decimal places. So what's smaller, 0 or 2? Hopefully you said 0. So that means we're going to round this number to have 0 decimal places, and that is 493. Okay. So now try this one. If we had 5.25 plus 2.3. That gives us 7.55. But how would you round that using significant figures? So hopefully you said it would be rounded to 7.6. Because again, this number has one decimal place, this one has two, so your answer should have one decimal place. Okay, so now when we're talking about multiplication and division, again, you have that paragraph long textbook definition, but what you need to know, your answer has to have the same number of significant figures as the number that you calculated with, whichever one has the smallest number of significant figures. That's how many significant figures should be in your answer. So again, wording this is kind of hard to understand, but what this means, 342 has 3 sig figs, 2.111 has 4 sig figs. Now, which is smaller, 3 or 4? You should say 3. So that means this number, our answer, needs to have 3 total significant figures. So when we round this to have 3 significant figures, you get 7.22. So when we're talking about multiplying and dividing, we're talking about all of the numbers in total. Addition and subtraction was just a decimal point. Multiplying and dividing is all of the numbers as a whole. So let's just do this one together. This first number has 1, 2, 3, 4, 5 significant figures. Now, how many significant figures are in this number? Hopefully you said 2. Now it's 2 because there is no decimal point. And with no decimal point, the trailing zeros are not significant. So that means our answer needs to have 2 significant figures. And so we would get 3.4. And all this other stuff can be dropped. Remember, these leading zeros are not significant, so we don't care about them. If, though, again, here is an if, there was a decimal point here, then that would mean there were 4 significant figures, and so your answer would be rounded to 4 significant figures, which would be that. But again, because that decimal point is not there, that is why it is that. So that's why it's super, super important to look for decimal points. Okay, so this is very kind of conceptual. It's kind of hard to grasp, but when we go through calculations all unit, this will make more sense. In the next video, we'll talk about dimensional analysis. Sounds kind of scary, but it is actually a really easy way and helpful way to convert between units. So, on that note, have a wonderful day.